Alrighty, everybody, good morning. Welcome. My name's Alistair Ashcroft. I'm the Technical Architect for Specifi and Kirk Roberts Consulting. Hopefully everybody can hear me. If you can't hear me at the moment, if you see a slide moving, you can't hear anything, please drop us a message or something in the window and we'll try and address it. So today's webinar is in two parts. We're going to have a short PowerPoint detailing the features of Specifi, followed by a simple technical session where we'll design a project, a foundation and a couple of structural elements. We'll also show you the expected outputs and talk to you about QA and consent documentation. Again, at any time, please ask questions. It's via the chat window, but I'll monitor that as we go along. So, what is Specifi? Well, Specifi is a complete New Zealand online engineering software. It allows architects, designers, people in the industry to design their own engineering solutions. Okay, it's been built by Kirk Roberts Consulting Engineers. It says on the slide here we've had 5 years of research. That's almost 7 now, so we've been under development since late 2011. It's had 7 years of development, research, innovation and industry engagement. So Kirk Roberts, we have offices in Auckland, Tauranga, Christchurch and just recently opened in Hamilton. We're about 115 staff, of which 60% are in the structural engineering business. We also have geotechnical engineers, civil engineers, fire engineers, and then we have a project management office as well. So why did we build Specifi? So post the 2011 Christchurch earthquakes, Jade and Damien, the two founders of the company, did a survey around the architects and designers in Christchurch and Tauranga. And we found that cost is the main factor not to use an engineer, but similarly time was a huge issue. So the goal was to build Specifi to improve the time it takes you guys to get your engineering results, and also the cost. Okay, so Specifi provides full system design. So what we mean by full system design is you don't design a beam or an item in isolation. Every beam or object you design has to be taken to ground. So you can design a beam, you then have to resolve it to a post or a connection, and that connection has to end up on a foundation. Okay, so we're not designing objects in isolation. We start with designing your loads and we take them to ground. So Specifi offers you the ability to save time. Okay, there's no need for you to consult for an engineer, giving you a faster design process. As a designer, you can sit here and go, what are my options here for this particular span? You could say, I've got an 8 meter span and I've got this load above it. What are my options? Software could say you could be this particular size in steel or this particular size in timber. So you can play with your designs prior to getting consent. Okay. Behind everything here becomes QA. When you do a design, before we will issue consent documentation, our engineers have to check it. So the goal is you submit your projects for consent, our engineers go away, go through your plans, go through your marked up drawings, and our goal is to return your completed consent documentation within two working days. There's a couple of caveats on that. It requires us to be given your completed consent documentation or your completed working drawings and the required information, and we've got guides that show you how to do that, how to mark it up so our engineers know what they're looking at. A very important part of Specifi is there's no additional risk or liability for yourselves as designers to use Specifi. It's exactly the same as if you engage with an engineer directly. At the end of the day, our engineers QA your work, we sign it off and we take the risk. We also provide feedback saying this would be better designed if you did such and such in a certain way. Okay, so our goal is to improve the quality of the designs that are going out of Specifi. So we're fully supported by a team of engineers. So as I said, we've got 65 structural engineers in New Zealand. So the residential team all use Specifi for all of Kirk Roberts' internal projects, and so they're behind us to be able to help. One of the main goals of Specifi is to improve the quality of engineering design and documentation. Gone are the days of a hand-drawn sketch from an engineer. You'll see when I generate a set at the end, we'll produce your documentation drawings, we'll produce the calculations for council, we'll produce producer statements and LBP forms for you to put in. With Specifi, there's no upfront cost to use. You can design as many engineering solutions as you like and only pay for those items you want to consent. You only pay one fee for QA and final documentation. That's an elemental charge, so depending on the number of elements you design, that charge changes. And we'll talk about that at the end. We'll show you how to get quotes and prepare quotes for your clients as well. If you need any additional design work, there are features to be able to request additional engineering. So Specifi is not the be-all end-all of engineering. So there are certain things we're not comfortable with designers or architects doing themselves. So there are features where you'll design something that falls out of the parameters we're happy with you working in, and the system will kick back and say, this requires specific engineering design. Request an engineer to do it. Also, there's other things that you can request if you're not comfortable. For instance, if you don't want to do the engineering yourself, you can submit your plans to us and we'll do the engineering using Specifi. Rightio, enough of the talk, let's jump onto a Specifi presentation. Okay, so just let me grab a different window. So hopefully by now everybody has registered for Specifi and perhaps logged in. So www.specifi.co.nz, and you can click on the login button to log in. I'll log in as a demo account. General use information for Specifi. At the top of each page there is a help section that tells you the information that we're after. Okay, there's also videos. You can hide the help screens, and I'll do that now, mainly because I want to be able to show you more information on the screen at once. And each page will remember those settings. So to start, I'm going to create a new project. So I'll click Create a New Project. I'll get the new project creation screen. Again, I'll hide the help. So just a couple of things as we work through projects here. Specifi uses a traffic light system. So green means good, orange means a warning or danger, and red means there's something wrong. So as I fill the project information in here, some things to notice. Every field that we ask for information on has an information icon beside it. If you click that information icon, it will tell you the field information we're after. So I'm going to fill some data in here. So I'm going to say this is the webinar example. It's for John and Jane Smith. All this information is just your standard information you'll have for your projects. You'll notice because I've entered information that I haven't saved, the project details are red. When I save the project later on, this will all turn green. I'll enter my project address. Now, project address is fairly important. One of the things it does here is it sets my address, but it also sets my nearest town. So nearest town is used to set our earthquake zone, our snow zone, and our council. Okay. We'll then expand the LBP form details. So we're seeing a lot of councils now requiring specific LBP details for projects. So I'm going to put in a PO box address here, it doesn't matter. PO box 123, and I'll put that in as Nelson as well. 7173. Okay, so if you need to provide clients LBP details on the LBP forms, this is where you put those in. Below that we have some site detail information. Again, all the sort of information you'd expect to see on your current projects. What's the shallowest roof pitch? I've got 15 degrees. What's my wind zone? If you click on the informational icon for the wind zone, you can go to the brand's website, punch your address in, and it'll tell us. I'm in a high wind zone here. I'm in Nelson, elevation's 10 meters above sea level, and I'm within 500 meters of the coast, so I'm in a high corrosion zone. Set my subsoil type. You can use a specific one if you know it, but otherwise just set it to very soft. Whether or not I want to design my foundations in Specifi, or if I'm designing foundations to 3604, that's fine as well. And then finally my ground and first floor areas, I've got a 150 square meter ground floor and an 86 square meter second story, and I'll save the project. So that saves the project and it takes me to the project dashboard. So the project dashboard can be thought of as the hub for your project. Okay, it has links to all the sectional areas we need to use, and it has some tasks that are required for your job. Okay, so the project details is where you edit your project details. You can see any invoices that have been raised. You can upload documentation for us and submit any custom requests if you had a custom engineering requests. So the foundation section allows you to enter your foundation geotechnical details. Give us a link to your geotechnical report if you've got one. Set your category of your land. The geotechnical report section allows you to request geotechnical reports, and then the foundation systems are where you go in and design whatever the foundation systems you have on your project. Over in structural elements, beams, lintels, joists and rafters allows you to design simply supported beams and lintels. You can design portal frames, cantilever posts. In the next probably month we'll release cranked beams and continuous beams. We're finalising the front ends for those at the moment. The documentation section allows you to generate consent documentation, well, preliminary documentation. Once you're happy with it, you submit it to us, we'll QA it, and then we'll generate the consent documentation. Then there's also a miscellaneous section where you can get some quoting. You can request additional engineering, for instance if you wanted a chimney design or something like that. Okay, so what I'm going to start with here is we're going to go and design a foundation system. But before I can design a foundation system, I need to enter my geotechnical details. So we just need to know a little bit about the land. So we can come in here, and if you've got an engineer's report, you can say who provided the engineer's report. Let's say Kirk Roberts did in this case. But if you've got a subdivision and it's developed to 3604, you can just click to 3604. Enter your bearing strength of your ground. I'm going to assume good ground. Depth to your bearing layer. Again, I'm going to assume cleared ground level. Do you meet the slope to distance requirements of 3604? So as your building's not on the edge of a slope and likely to be moved away, if you don't meet those requirements, you will need to have specific engineering design. And as you come down here and answer these questions, Specifi will tell you whether or not it can do the design of the foundation systems for you. And then finally, what's the land classification you've got here? So the majority of the country has unclassified land, but if you're in Christchurch or Tauranga, you'll start to hear about, well, if you're in Christchurch, you'll definitely know about the technical categories of land. So we have TC1 land in Christchurch. We have TC2 or liquefiable land. So that's in Christchurch as well. It's also in the Mount, places like that. And then we have expansive clays. So if you're in Auckland and you're on expansive clays, you can design foundations for that as well. So I'm just going to do regular or TC1 unclassified land. I'll just do unclassified. And I'll save my geotechnical details. SED is not required, so specific engineering design is not required, so I can do it myself. So I'll go view foundation systems and I'll create a new foundation system. Now something I'll explain now that I didn't explain when we were on the dashboard because it wasn't very long is across the top of the screen here we have a crumb trail. So the home icon obviously takes me to my home screen, my projects takes me to all of my projects, then the specific project dashboard. And now I'm in the geotechnical details section. I'm looking at the foundation systems, and I'm looking at a specific foundation system. So we can start and design a foundation system. Specifi allows you to design 7 different types of foundation system. So a standard foundation where you have a concrete footing and you pour a slab over the top. A monolithic foundation where you pour the slab at the same time as the footing. A strip masonry where you've got masonry blocks on some form of blocking. A thickened slab edge, which is an on top of ground preformed foundation. A waffle slab, which some of you may know as a rib raft. Timber foundations, and finally foundation retaining walls. If you've got a slightly sloping site and you need a foundation retaining wall in the middle of it, you can design that retaining wall up to 3.2 meters and say I've got a slab on top and I've got a slab on bottom, and this is how I want to design my retaining wall. Okay, depending on the depth to my bearing layer, I'm going to choose a standard foundation for this example here, but depending on my bearing layer, it's going to say what ground improvement I need. For instance, if I had a bearing layer at 600 mils underground, it would be giving me options to have a raft, or take my foundations down to the 600 mils, or to put site concrete or a compacted trench. Because I've said my bearing layer is at ground level, there is no ground improvements required. I'll give the foundation a name. I'm going to call it the main house foundation. I'll set my concrete strength, my height out of the ground, and my slab thickness. Okay, so finally what I'm going to do here is I'm going to give it some initial settings for Specifi to size my foundations. So based on the weights that you know about from 3604, what's my biggest roof span? In the example that I'm going to show here, I think we have a 9 meter roof span. So I'll punch in a 9 meter span. My wall is 2.6, it's a lightweight wall, but it's 2.6 meters high on the ground story. This is a 2-story project we're going to work through here. And my floor has a 5.2 meter span at the biggest intermediary span. So I'll save that foundation system. and Specifi will go away and create me a number of foundations. So because I've got a 2-story foundation, it's created me external 2-story foundations and external single-story foundations. In case I have a different requirement for the width of my foundations between a single story and a 2-story, I can simply rationalize those to my biggest foundation size, and that's probably the most cost-effective option, to have a single edge foundation and perhaps my internal thickenings where they're required. Okay, but it will generate these for you automatically. You can go in and tweak these and say, actually, my lower wall is heavyweight, but it may be brick, and my upper wall might be lightweight, and you can specifically design the foundation. If I go into one of these foundations, such as my external 2-story foundation, so I do that by clicking on the hyperlinks on the left. If I go in here, you can see I've got, the first thing you can see is the load case I'm designing for. So I'm designing here for a perimeter 2-story foundation. So on the picture on the right, you can see that I'm looking at a foundation that is supporting 2 stories. Okay, so it's supporting a roof, 2 walls, and a mid-floor. Okay, it's been labelled as the external 2-story foundation, and then I can tweak my weights. So because I said there was a 9-meter span, it said my upper roof is lightweight with a 9-meter span, and it's got a 0.6 meter eave overhang. My upper wall is 2.6 meters high and it's lightweight. In my example, it's actually 2.4 meters high. That's the ground floor is 2.6. So I'll save that as 2.4. My lower wall is lightweight at 2.6 meters, and my biggest floor span in the mid floor is 5.2 meters. So I'll save that foundation. So that's updated the foundation. It hasn't made a difference to the size of the foundation. That's because there's so much excess capacity when we're looking at 300 kPa bearing strength in the ground. And then it's given me a designed foundation over to the side here. So if I click on the foundation, Specifi opens and shows me the foundation system that's been designed. So I can see the width of it, and in the detailed outputs we'll be able to see the particular type of steel that's required. So this here's got D12 starters at 600 centers. Okay, so that's our design foundation for our external 2-story wall. I can then use my crumb trail across the top to either go back to the foundation system, where I can see the 6 foundation systems that were created. Okay, or I could go in and create a different foundation system, such as retaining wall if the site was on a slope or something. I'll now jump back to the project and we'll go and create a couple of structural elements. Okay, so I click on my project link on the crumb trail across the top, and I'll come in here to create some beams, lintels, joists and rafters. Now everybody, hopefully if you got the link for the webinar, you should have been sent a link to some downloadable plans. So what we're going to design here is the plans that link contained are a 2-story project we've been working on. So this is the ground floor plan, and what we're going to do here is we're going to design a number of beams. The first beam we're going to design here is the beam that sits above the lounge, that spans the lounge, and then we're going to design, so this beam here, so a couple of things before we start a design on Specifi. We need to identify the beams that need to be labelled. We can arbitrarily call those beam 1, beam 2, beam 3, beam 4. For ease of design, you should start by designing your highest or topmost beams first. So what that means is, beams at the top of the building need to be designed first, but also beams that land on another beam need to be designed first. So this beam I'm designing here, structural element 1, I've arbitrarily named one end N1 and one end N2. End 1 is actually going to land on another beam, so I need to design structural element 1 before I design the beam that it lands on. Okay, so we've arbitrarily called an end E1 and another end E2. So we're going to design this particular beam, and then we're going to design the beam that it lands on here. So SEO2 is the beam under the upstairs wall. So this beam here has 2 posts on each end, and they land on the external foundation system for the property. And then it has a point load that lands in the middle, which is structural element 1, end 1. So those are the 2 beams we're going to create. So let's go and start by creating beam 1. Let's minimize the picture. So we're going to create a new beam. Our options for creating beams are for simply supported structural elements or cantilever elements. Now I'm sure everybody knows what they are, but a simply supported element is one that is supported at each end. A cantilever element is where you have one end overhangs. So let's create element 1. So a simply supported element. Now Specifi lets you design a number of different element types. So this particular element we're designing here is a beam. So an important point to note with a beam is in the same plane as the rafters or joists that it's supporting. Okay, whereas a lintel obviously sits below the rafters or joist. So Specifi will allow you to design beams and lintels, ridge beams, sill trimmers, rafters, purlins, joists and bearers, and wind beams. Okay, Specifi takes account of wind loadings on elements. So if I click on the drop down here, you'll see another couple of options. So you can see I can design an external lintel. The first option is within 400 mils of a top plate. I've then got two items where the external lintel is more than 400 below the top plate. In the case when you're more than 400 below the top plate, Specifi will design the lintel for face loads or wind loads as well. Okay, so it will ask you the opening of the window or the door below it and design for those things automatically. In this case here I'm designing a beam, so I'll choose a beam. Okay, now element 1 was supporting a floor. If you've had a chance to look through the plans or you'd had a read of them, the beam span of element 1 is 4.8 meters and its deflection limit is standard. So what does deflection limit of standard mean? Okay, so Specifi gives you two options for deflection: minimal deflection or standard deflection. So typically in New Zealand, engineers design beams or elements to have a deflection limit of no more than 12 millimeters or no more than the span of the element divided by 360. So if you had a 3.6 meter long beam or 3600 millimeter beam, would allow no more than 10 mils of deflection. Okay, if you click on the information icon, this will break it down more for you. But the real crux here is, where you're designing a beam or a lintel that is above an opening, you want to have minimal deflection. Okay, if you've got a 6 meter wide stacker slider, we don't want to allow that beam to deflect by up to 12 mils because the door might stick. So in the case where your lintel or beam you're designing is above an opening, the basic rule of thumb is go to minimal deflection. Okay, but that's your rule of thumb. Design for standard deflection is generally okay unless you're above an opening, in which case you want to choose minimal deflection. Okay, we'll label this, so this is going to be called the beam over the lounge. And if you look back at the house plans here, we look at element 1. So element 1 is supporting floor joists that are perpendicular to the beam we're designing. So you can see in here that the joists are at 600 centers, and the distance between the two load-bearing walls that this beam is supporting is 5.2 meters long. Okay, so it's a lightweight floor, regular lightweight floor, and it's got a 5.2 meter span. Okay, so below, when I'm asking for spans or element dimensions, there's a help window that comes up below that tells me what it is we're asking for. What is the dimension we're asking for? So if my joists are perpendicular, my floor span is the width between the two load-bearing walls. That's the picture on the left. If my joists are parallel and perpendicular, the span is the distance between the first parallel joist and the load-bearing wall. Whereas if both my joists are parallel, it's just the distance between those two joists. So basically you need to think about the direction of the beam and the direction of the load you're picking up. I'm sure that's not new because that's how you design an element to 3604. So I'll click Save the Beam Information. You'll notice that the beam information went from red to green, and now I can enter any point loads. Now this particular beam, SEO1, doesn't have any point loads, so I'll go and show the available members. So now what Specifi does is it presents me with all of the members that work for that particular size element. Now it says that a 180 PFC works. Some information about a 180 PFC. It says it gives me its height and its width, so I can check those things. But it's also telling me that the midspan vertical deflection is 9.88 millimeters. Well, this is the theoretical vertical deflection, the maximum theoretical vertical deflection, and it gives me a rigidity ratio of 1.21. So rigidity ratio is a measure that engineers use that tell us how much a beam is deflecting compared to how much it's allowed to. So a rigidity ratio of 1 would mean that a beam is deflecting at its maximum limit. Okay, so if I had an allowed deflection of 10 millimeters and we had the beam was deflecting 5 millimeters, the rigidity ratio would be 10 divided by 5, or 2. Okay, so the higher the number, the easier the beam is catering for the load, if you will. You can see here I can filter the types of options that appear. You'll see it, we're product agnostic, so we'll show you all of the steel options, all the glue lams, the timbers, the tech lams, all of those sort of things. And I've got some filtering options I can use. So I can sit here and go, well, actually I need this to fit within a 240mm high, and I need it to fit within a 90mm wall, and I'll refresh the sizes. So basically, because I need it to fit in a 90mm wall, it's bringing me back to my steel options. So for this instance here, I'm just going to choose a 200 PFC, and I'll save that member. Okay, it's now asking me to design my end connections. Before I jump onto the end connections, I just want to point out the graphic at the top right. So as you design your elements, there's a graphic gets drawn at the top. Now this is not a shop drawing type graphic, but it is a 2 scale drawing. So I've said my beam is 4.8 meters long, and at the moment it believes it's going to sit on two 2.4 meter high posts. So if that picture doesn't look like what you're trying to design, maybe you've got a measurement wrong somewhere. So while it's not an accurate detail of how the connections work, it is an accurate 2 size representation of what we're doing. So I've said that end 1 is going to be a point load. Okay, so rather than connecting it to an engineered post, I'm going to say that end 1 is going to be a point load on a to be confirmed beam. So I'll choose that. Now I could carry on and design end 2 and then do my base connections, but for speed here what I'm going to do is I'm going to save that, and I'm going to jump out and design end connection beam 2 first, so that I can then land this on it. So I'll save my end connection. Okay, you can see my end connections are still red because I haven't designed end 2, and end 1 is still not decided where it's going. I'll use my crumb trail at the top to jump back to my structural elements section. It's showing me SEO1 that I've created, and it says my end connections are not yet finished. I'll now create another simply supported element. So this is where I'm going to create element 2. Okay, so this is where I'm going to create SEO2. Now this is the beam under the upstairs wall. So this beam spans from the 2 load-bearing walls on either side of the foundation. So its length is 5.2 meters long. I'll show you the load case in a second, but this beam sits under the upstairs 2-story portion of the house. So it's supporting the upstairs roof, the upstairs wall, a portion of the floor load where the joists are parallel to the beam. And if I go through the plans, which I can do at the end, I don't have them open here, but if we look at the plan, it also has a lower portion of the roof, a 1 meter span of the roof on the ground floor. So so that's the loads that it's supporting, and then it also has the point load from end 1 coming in at the mid span, or 2.6 meters along the beam. Okay, so let's jump back here. So again, this is a beam, as in it's in the same plane as the floor joists. And now instead of just supporting a floor, this is supporting 2 roofs, a wall and a floor. And its length is 5.2 meters. Deflection limit is standard. Now, if you recall, when I designed the first beam, the floor load, when I was entering the floor load, the span for that was 5.2 meters, which happens to be the length of this beam. And that's because these ones are running parallel. This is parallel to the beam, but that's the same area that was being picked up by the first beam. I'll label this the beam under the 2nd story, and then I'll go and put the loads on it. So from my plans I can see that the upper story roof had a 5.6 meter span, and it had a 600 mil eave overhang on it. Okay, so the eave overhang was 600 mils. The lower roof, which was the roof on the ground story, had a 1 meter span. The wall on the 2nd story was a lightweight wall, and it's 2.4 meters high. And finally the floor, as the floor joists are parallel to the beam I'm designing, it's just the joist spacings, and they're spaced at 600 mils. And I'll click Save on the beam information. So now it's taken me to the point load section. So this time I do have a point load. So I'll click Manage Point Loads, and I'll click New Point Load. Okay, so now I've got the new point load screen. So for my point load, I come along here and I've got two options. I can enter calculations from a truss manufacturer. So if I've got a truss report, I could put those loads on the beam. But in this case, I'm going to choose structural element 01, the beam over the lounge, end 1. So because I'd said that beam 1, end 1 was going to be a point load, I can now assign it. It lands on the backspan. This is a simply supported beam, so it only has a backspan. But if I had a cantilever beam, my options would be on the backspan or the cantilever. And it's located 2.6 meters along the beam from end 1. I'll save that point load, and I'll return to the structural elements screen. Okay, we'll get a message box here telling me that this message here is telling me the loads have changed on the beam. So Specifi continually checks itself. So if I was to finish my design and I would go in and change the loads on beam 1, it would invalidate beam 2 and make you resave it to recheck it. So it's telling us that it's been invalidated because the settings of the supported elements have changed. So you can now see we've got a point load which is beam over lounge end 1. It's located on the span, 2.6 meters along, and then you can see the loads come in. Likewise, if you had a truss manufacturer's load, you could add truss point loads as well. If we look at the graphic being built in the top right, you can see we've got 5.2 meters long. We've got a point load coming in at 2.6 meters. We don't yet have a beam selected, but when I choose a beam in a second, it'll draw the beam. Okay, so I'll now go and show my available members. And again, Specifi is presenting me the members that work. Okay, so I'm going to select a 250 PFC, and I can see that's deflecting 7.4 mils at the midspan, so less than our 12 mil deflection limits. So that's all good. Over on the right here, I have a profile of the element, so it's 250 mils high and it's 90 mils wide, so it works within our 90 mil wall, which is great. I'll save that member. And I can now start to design the end connections. So, what are my end connections? Now, I said earlier on when I showed the image that N1 and N2 are both 2.6 meter high posts that land on the external two-story foundation of the house. So because they're the same, I can make both ends the same, but I could design each one differently. Just for speed here, I'll say they're both the same. I'll say they're an engineered post. It's 2.6 meters high. Specifi shows me the allowable types of posts. I'm going to use a triple stud here, and now I'm going to go and design the connection detail. So Specifi is going to show me the connection details that work based on my demand going down and my uplift if I had roof loads. Okay, so where wind is a factor, it will be only showing connections with enough uplift. So the different connections options I've got the first one was a perpendicular beam. This beam here has been trimmed at the top to fit within a roof space. Okay, I'm going to choose the 90 degree, so that the beams that are 90 degrees to the triple studs. I'll select that, and I'll save the end connections. So almost finished. You can see now the image has been updated at the top to now show my 250 PFC on my two 2.6 meter studs. So now I need to choose the base connections. So far I've designed the beam, I've designed the end connections, and now I need to choose where they go to ground, the base connections. So my options here are, what are my support types? So I've got my main house foundation that I created before, but I can also land this particular base of the post on another beam. So Specifi continually checks the global deflection. So you can land a beam on a beam on a beam on a beam. Okay, to within reasonableness standards, of course. Okay, so our engineers would have to be happy that a beam on a beam on a beam would work, or was the best choice for what you're designing. But if I had a ridge beam and that ridge beam landed on a post and that post came down and landed on a lintel over a window, this is how I would design it. My ridge beam post would land on the lintel and become a point load on the next lintel coming down. In this case here, I'm saying it lands on my main house foundation, and then I've got the foundations that Specifi automatically created for me. The external 2-story, the external single story, as well as some internal options. I then have another couple of options. So one option is an isolated external pad, so a pad outside of the foundation system. An internal pad foundation, so where the post just lands in the middle of your floor. And finally a pad under a slab edge. So one of the things that can happen when you design a foundation, especially if you've designed to 3604, is that your external foundations aren't big enough and we can require a pad to go under the slab edge. Okay, in this case here they're just going to land on the external 2-story foundations, and I'm going to say that both ends are the same. I'll now choose my base detail. So how do I connect my post to the base detail? I'm just going to use an option where they sit on a bottom plate, and I'll select that image and I'll save my base connections. So good stuff. The traffic light has told me everything's green, okay, and I could use my crumb trail at the top to return to my structural elements, or alternatively I can go take me back to design another structural element. So now what we can see is structural element 2 has been completed. Structural element 1 is still waiting on us to select its end connections. So let's quickly jump in and finish structural element 1. So I'll click on the hyperlink for SEO1. When I open up, Specifi says please check the connections as N2 is invalid and the post capacity is no longer sufficient. That's just because before the first time I didn't save it. Okay, so I'll click on the End Connections tab. We can first of all now see that structural element End1 is now a point load on a 250 PFC. Okay, so let's choose a connection detail for that. So how does my 200 PFC connect to my 250 PFC? Well, it's not on a post. We don't want that. This one's in the floor space, so I could use a bottom flush one, but I'm going to use the top flush one. Okay, so basically my 200 PFC and my 250 PFC are top flush aligned, so I'll choose that. Something else to point out to people that I probably should have said before now is if none of these images are what you want, you can come across here and you can go, look, there's no connection detail that works for me, and if you choose this option, we'll contact you and we'll look at creating you a custom image. Okay, so if none of the stuff we've got works, okay, so either there's nothing shown here, which can happen if you've got huge uplifts or huge downforces, though we do have some fairly big capacities, but if you've got something that doesn't fit, let's say you've got a raked roof and you need a cambered end, you can contact us and we'll generate a custom image for you. But in my case here, I'm going to choose top flush, and I'll save that. Oops, I didn't mean to click save then, I meant to go and design N2, so I'll jump back, I'll just go back to my tab, and I'll say that N2 is an engineered post. Now again, the ground story is 2.6 meters high. This one's allowed to land on a double stud, and I'm going to select a connection detail for that, and again I'm going to have it coming in at 90 degrees. So I'm going to have my beam coming in at 90 degrees to my post. I'll select my image and save that. And finally, I've now got to choose my base connections. So base connection for end 1, there is no post, there is no base connection because end 1 is a point load. And for end 2, if I quickly jump back to the picture, and I turn on post 1, you'll see that N2 is actually just a pad, there's no foundation here, so I'm going to design that to be an internal pad. And instead of choosing an external 2-story foundation, I'm just going to go an internal pad foundation. I'll select my base detail for that internal pad foundation, and I'll just have it landing on a bottom plate. Any of the pictures work, there's no uplift, this is an internal image, and I'll save my base connections. I've now got everything green, and I'll return to my structural elements. Okay, so now both of my elements are completed. So I've got a 200 PFC for structural element 1 and a 250 PFC for structural element 2. So let's jump back and get some documentation going. So I'll jump back to my dashboard. Sorry, I'll just wait a second, I've got Jamie typing something here. Can you have two beams perpendicular landing on a post, i.e. the external corner of a building? Yes, you can, but we require a specific engineering design for that. You've got a couple of options for it though. You could actually land end 1 millimeter along the other beam as a point load. So you can put the beam as 0.001 mils along it, and then just request a custom design. So we'll show you, we would have to check the design of the post. Putting it on as a point load will make sure the post is correct, but we'd just do a custom drawing for you for it, if that makes sense. Yeah, so yes you can. We would just put one point load 1 millimeter along one of the beams, and then the second one we just have to do a custom drawing for the post. So great question, thank you. Okay, so we've now created our project, designed a foundation system, and we've designed a couple of structural elements. So let's go and have a look at the documentation that we can generate. So I'll come into the documentation section, and we can see here, so basically we've got a fairly busy screen here. If I expand the help, it'll explain to me what's got to happen here, but just for real estate purposes here, I'll leave it the way it is. So basically we're going to try and get this screen to go across to the consent tab. So the summary tells me we've created a project, one foundation system, 6 specific foundations which Specifi automated for us, 3 foundation point loads, so those are the loads from the beams that have come down to ground, and 2 beams. So I'll click on the preliminary document section and I'll generate a set of documents. Okay, so not all documents will be available here to you at this point. The reason is until we do our QA checking, we don't want a set of calculations to go out to council, because we may have an incorrect load somewhere. But if I click on the preliminary set, so the documentation set I've got here, I can view the structural documentation that's been generated. But to most users you can't see the calculations, they only come out once we've consented it, as does the LBP form and the producer statement. In a couple of minutes I'll log in as my administrator account and I'll show you how those things look. But let's have a look at the structural documentation first of all. So I'll download a set of the structural drawings. So this is for my webinar example for the project listed here. Table of contents, so we've got some general sections where we explain comments, abbreviations, additional details. So based on the types of elements I'll get some additional details, and then you'll see we've got a connection fixing table. I'll touch on that quickly. Okay, so there's some typical details for when we've got PFCs coming into timber to show how those things should connect. But then you'll see here we've got a connection, fixing and manufacturer information. The reason we've got this is when you look at our detailed drawings, you'll notice rather than us saying this is a Mytech or Lumberlock sheet brace, or a Prider this, or a Simpson strong tie this, we'll use a KR code. Okay, so KR 111. Okay, and then we'll tell you these are all the manufacturer ones that are equivalent for it. So you'll see here I've got a concealed purlin cleat, a KR 140, and that can be a Mytech or a Lumberlock CPC 80 or a Prider MPP C8 or a Fortress CPC L bracket. Okay, so rather than our details having all of those different options on it, they'll just refer to a KR 140, or in the option below a KR 140 stainless, okay, which is what the KR 140S is. Okay, I'll then get my foundation system drawings. So here's my external foundation that we've created, and then you can see I've got 2 point loads on it. Okay, so there's a point load, the triple stud from structural element 2, and the triple stud from the triple stud from structural element 2 end 1, and the triple stud from structural element 2. It says you don't need to improve the foundation, so there's no need to make the foundation bigger for that, but there is an improvement length of 1300 millimeters. So an improvement length means another post can't land within 1300 mils of that post. Okay, so if you're trying to check that yourself, that's what that's telling you, but it's also what our engineers will check in the QA times. And then we'll get a detail for each of the different foundations that I had. Something I didn't touch on before that I can come and talk to you, I can come and show you at the end of the webinar, is there's also a list of user selectable typical details you want to come out with it. So you can choose to include a control joint. You can choose to include a typical saw cut joint. If you've got rebated showers or non-rebated showers, you can say, show me the rebated shower option. Show me the rebated shower option when my shower's on a slab edge. So you get to customize those drawings to decide what to choose. And that's done from the foundation system that I'll show you shortly. We then get our beam documentation. So here's structural element 1. Okay, so it's got the schematic, the indicative image of what we think you've designed. So this is a 200 PFC, and here's how it connects to its end connection on the end 1. End 2 is landing on the post, the 200 PFC. We chose a double stud, and that double stud lands on, that comes down and lands on the base connection below that. It's also saying there is no base required, okay, because it's a point load. And then we'll get structural element 2. So here's structural element 2. Again, it's got a point load coming in 2.6 meters along from the end, and end 1 and end 2 are the same, both landing on triple studs. Okay, so this documentation set here is for you to be able to check and use. If you just excuse me half a second, I'll grab another window and I'll just log on for me as an administrator, and I'll show you the calculations and the calculations, the LBP forms and things like that. So I'll just log in here for a second, different screen, and I'll go into that project, and the project number is 1941159, so just bear with me while I do that. And I'll just move this window over the top for a second. So here we have the quality assurance section now. So this is the same project, but this is logged on as my administrator account. So if I come in and look at my preliminary drawings, I can show you the calculations. So this is the working calculations that will go to a council once we've signed QA off. So as you come through here, you can see all the calculations we build for everything. So let's go and look at a particular beam. So the first item is, so we've built these calculations after working with numbers of councils around the country. So here's the design summary. So this is basically what's been designed and what the loads are. Then they'll get a table of the QA information, so everything that we've checked and who's checked it. So the floor, in this instance, basically everything that's been as an input has been checked here. So the floor is a lightweight 1.5 kPa floor load with a 5.2 meter span, and who from us has checked this information. Okay, then we get loading tables, and then the calculations as to why things work. So the big part of this is trying to improve the quality of documentation that goes to council. Okay, so that's the quality of the calculations we output. We then have an LBP form, so an LBP form for you to submit saying what's been designed. So in this case this is preliminary, so it won't be signed, but when we do the consent level documentation you'll get that out, who it's for, what we've done, and then the particular elements that have been designed. So foundations and subfloor framings in these particular drawings, they've been supervised by us, and in this case columns and beams, so for the particular structural elements. So the LBP form ready to go to councils, and then we'll have a PS1. So a PS1 down here saying what we're covering. So standard PS1s detailing the particular design levels we've gone to and what drawings are included, and then finally at the back here any schedule of inspections that are required. Okay, so foundations should be checked prior to closing in. That's got a caveat on it that says that local councils can at their own discretion inspect these themselves. Okay, but depending on the types of objects you build and the complexity levels, for instance if you put a portal frame, a steel portal frame in here, it will require an engineer to check it prior to closing in. If you have TC2 foundations, we'll need to check steel before things happen, and grids. Okay, so it's depending on the type of objects you do, the inspection schedules will change. Okay, so the goal for yourself as a user, now I'm just going to turn off that one because that's my administrative account. Turn that off. Okay, so the goal for yourselves as users is to get items ready for consent. Okay, so we've got our summary that shows what we've done. We've generated a set of preliminary documents that we're happy with. We'd now be ready to upload our supporting documents. Okay, so basically we want you to upload the information we need to be able to check. So we need to see the project information. We need to see a site plan and elevation details, foundation details if you've got the. We need to see foundation details, and if you've got a geotechnical report, upload those things. So I'll select a set of documentation to upload. Okay, and so over on the other window it's asking me for where I want to get them from, so I'm going to go to my documents, webinars folder. So in my webinars folder I've got a full set of plans here, so architectural drawings with notes. So I'm going to upload my drawings, and I'm going to call it the full plans, and I'm going to say this includes the project information because it tells me where the project is. It's got the site plan, it's got elevation details, and it's got the foundation details. I'll upload that. So that'll upload to our server. It'll take a couple of seconds, it's quite a big file. Yep, so that's uploaded, and there's a copy that our engineers can now use for doing the review. Okay, so at this point I'm ready to assign something for consent. I'll show you how we do that. Now, I haven't uploaded a geotechnical report. If I had one, I could upload that. So when I click on assign for consent, it's going to tell me that you haven't uploaded a geotechnical report. That's not mandatory, it's just a warning. Okay, it says it hasn't been uploaded, so we may not be able to do the QA checking. Okay, it is possible in this case, but it depends on the type of document. If you haven't given us elevations, we won't be able to see what a wall load is, for instance. Okay, so now I can choose what I would like to QA. So I need to QA my project, I'm going to QA my foundation system, and I'm going to send the 2 beams for QA. Okay, if I'd done 4 different variations on a beam and I decided to only go with a particular option, just don't send the other elements for QA, or go back into the project and delete them. It's up to you, there's no issue. We only charge for the items that you consent. We'll talk about the pricing fairly soon. We've priced the whole of Specifi at about 50% of the typical cost of an engineer. Okay, so that's what you'll see the prices come out to be. So I need to now confirm that I've checked the accuracy of this information. There's a little caveat here telling you that we don't check the job name, your client's name, or the legal descriptions, and the LBP owner details. So we can change those later on, but it comes with a charge for changing those. So just make sure they're correct. There is no need to submit items for QA until you've completed them, right? So do your initial designs, get your sizes ready, complete your designs for your clients to make sure they're happy, and then submit for QA. Because you don't want to submit a beam for us for QA to then go back a month later and change its size or location. Okay, because we'd have to check it again. So I'll go OK to that, and I'll submit these ready for QA. Okay, so I'm now ready to pay for consent. So if I come across to the Pay for Consent tab, there's a couple of different options that can happen here. I've got this project is being created by me just as a personal project. So the first thing I can do is there's 10 objects waiting for consent checking. I'll create an invoice. Okay, so that's created me a $592 invoice. We'll go through pricing shortly. But my option here is to pay that invoice. If I click pay, it will take me to a payment gateway and I can put a credit card in. If you're going to do lots of this, what we'd recommend is, or if you've got a company, create your company. You can apply for a credit account with us. Once you've got that, you can just put it on your account. Now, creating a company doesn't mean you require an account, but a company is beneficial because it means you can share your project with other members in your team. So you could have 2 different draft people or architects. They could both belong to the same company and they can both work on the same projects. Whereas at the moment, this is a personal project and only I can see it. So if I click pay on the invoice, I won't pay this, but I will acknowledge that I'm happy to do it, and it'll take me to a payment gateway where I could make the payment. I'll jump back from that. I don't need to pay the invoice. This is only a demonstration project. Okay. At that point, when I make the payment, it comes across to Specifi. We get told, hey, this is ready for QA, and our people will start QAing it. We'll send you back information if you haven't supplied the correct drawings or you haven't marked it up, and we've got some guides to tell you how to mark up. So clearly, when you label a beam BO1 or beam 1 or lounge beam, we need to know where that is. So as long as it's consistently marked up so our engineers can QA check it, that's the important thing for us, and we've got guides to show you how to mark those things up. Okay, so A couple of other things I'll show you how to do is to be able to prepare quotes. Now, one of the things we fully designed Specifi for was to allow architects and designers to be able to recover their time for doing their engineering. Okay, so we offer architects and designers wholesale rates, but we give you the ability to generate a retail invoice for your clients. You can choose to do that or choose not to do that, that's up to you. But we'll show you how you can price the different options. So once you've created your project, what you can come along here is come along and create a quote. Okay, so we'll click on quotes for a second. So we can create some quotes here, so I'm going to create a quote. And I'm going to do this based on wholesale or resale values. So I could do it based on the current project. I'm just going to do a manual one because that's going to allow me to add some additional engineering to the quote. Okay, so this is a quote for a client, for instance. Oops. Quote for my client. Quote for my client. When we've done it, what the classification of the land is. So I'm going to say TC1. If I'd based this on the project, it would have known that I'd had TC1. I've got a single or two-story dwelling, and I'll show you the difference between resale and wholesale prices in a minute. So you have to have a project. We need to be able to QA that you're in the correct area, the wind zones are correct, the snow zones are correct. So now I can add whatever elements. So I'm going to say I'm going to create a foundation system, and that's just going to be a standard foundation with up to 7 foundation systems. So that's got a price of $2.95. I'll then go and add a number of structural elements. So my structural elements are my simply supported beams or my cantilevered beams or my cantilevered posts. So I'm going to have 2 of those. So you can see that a beam's $95. For us at Kirk Roberts, we're typically $160 to $190 a beam. So I'll add another item. So you can see the 2 structural elements I've added. I can come along here and design a portal frame. And if people have got a couple of minutes, I'll show you how we can design a portal frame and how we can design a portal frame to take a bracing requirement that we've got. Okay, so but other options I've got here, I've got some additional engineering. So I could say, well, I want to know about a chimney design or a perimeter foundation wall up to 2 meters high, or I need a hot water cylinder seismic restraint, or I need a bracing design. So we'll get engineers to go and do bracing designs. But excitingly, we're working on a front end for bracing at the moment, where you can come along, put your grids in and go, brace this to me for engineering purposes. So engineered bracing is a wee bit different to 3604 bracing. So we work on tributary areas and tributary widths rather than just brace lines. Okay, so that's general additional engineering, but I might have retaining options where I might need some driven timber piles and things like this. So I can request additional engineering in here as well. I won't save that quote, but I'll jump back to the project for a second. It says you're going to lose your changes. That's quite, I'm happy to lose those. So under the miscellaneous section here, I can also request additional engineering. So if I click request additional engineering, so there's some options here for us. How about, so you can say, I want to know about balustrades and handrails. So we can price that for you. Or bracing, or fire reports, or a PS4 site check. Okay. We've got options here where you can say, give me a quote for the Specifi team to perform my engineering, okay? And we'll tell you, yeah, we can do this and it might take a week. So one thing to notice is while we say we can do QA, or we attempt to do QA within 2 days, we won't necessarily be able to provide additional engineering within 2 days, okay? So that does depend on our workload at the time, and it does depend on when you accept the quotes. So if we've got free time at the moment and we say it'll take 2 days and you come back in 2 months time, those time frames may be incorrect. So that's just something to be wary of. Okay, so that's the fairly quick walkthrough of Specifi. Some other areas where people are using it lots are in our portal frames. So where you need to get use a portal frame to get some additional bracing, fairly simple to use. So you'd come into the portal frame section, you'd create a portal frame. Okay, so your options for portal frames are a 3-member portal frame or a 4-member portal frame. So we'll design a 4-member portal frame quickly. Okay, and what does it support? This is supporting a roof and a wall, or just a roof. Let's say it's got a roof only. So let's say this is a gable end portal frame. Okay, again, my deflection, whether it's a standard deflection or it's got an opening underneath it, I'll leave it as standard. So now it's just a simple case of geometry. What's my left hand side post height? I'm going to say 3.2 meters high. Oh, if I could, I've got my num lock off. Yeah, if I can go 3.2 meters, num lock, 3.2 meters high. And where's my apex? Now you'll notice as I'm changing these numbers, the schematic that's being drawn is changing. So I've now got an off-centered portal frame, okay? So that this geometry can be used for whatever your geometry is you're trying to build. Okay, I'll leave an off-centered one like this, and then it says, well, how much wind bracing do I need, and how much earthquake bracing do I need? So we have got, let's just change this for a second to a 3-member portal frame. We'll make both posts 3.2 high, so we'll make a rectangular one. 3.2 meters on the axis on the side and 3.2 meters on the post. Okay, so I've now got a rectangular portal frame that's 5 meters wide. We'll make it 6 meters wide. Okay, a 6 meter wide by 3.2 meter high portal frame, and I can now say, well, actually I need 360 bracing units along that thing for wind, because I've got no wind bracing, and I need 180 bracing units for earthquake. Now our new bracing tool that we're building will tell you what's missing, and you'll be able to design a portal frame based on the missing bracing requirements. So I'll save that. It'll now say, well, what's the height of my roof? What's the loaded dimension of my roof? So let's say this was a lightweight roof, and it was trussed, and the trusses are at 1.2 meter spacings, so 1.2 meter spacings with no eave overhang. My wall is only 400 mils, so the portion of the portal frame that's in the wall is the only wall load I have, and I'll save that. I can put point loads at any point along the portal frame, but I'm going to have no point loads, and it's going to design me a portal frame. So it says I could use a 250 PFC, or I could go to a 250 UB. I'll choose a 250 PFC. I'll save that member. Now exactly the same as a beam, as I said earlier on, all elements that you design and specify have to go to ground. You can't leave anything that is not completed. So where does it land? I'm going to say this lands on my external 2-story foundation. I'll make both ends the same for speed, and I'll choose my base detail. So you can see here I've got some bolts being drilled in, and there's some cast-in bolts coming here. So there's different options based on what's required. I'll choose those, I'll make them the same, and I'll save my base connections, and now I've got a completed portal frame. Okay, so that's the complexity for a portal frame. So if you need bracing, portal frames are a simple solution for it. If you've got, for instance, a big glass wall. So back to my portal frames, that's a completed portal frame, and if I was to generate my calculations, I'd have those. Rick's asking a question, which is great. One other thing I touched on before and haven't shown you is how I can choose which custom drawings I have when I'm looking at foundation systems. So when I've got my foundation systems here, if I go to my foundation systems, you can see I've got my main house foundation, so I'll drill into the main house foundation. Now, as well as the foundation systems that were automated by Specifi, you can see I've now got a number of point loads on my foundation. Okay, I've got a question here from Rick. I'll go back and address that in just a second, Rick. But I'll just show you how to choose your additional details first. But now that I've designed my foundation system, you can see that I've got the point loads and where they are and what improvement length or width is required on those. Okay, so this updates as we put elements on things. So back in the foundation system here, I can select additional details. So if I choose select additional details, at the moment you can see I've got a control joint and a saw cut. Okay, but if I look over here on the right, I can choose to have an internal shower, or I could choose to have a shower on a slab edge. Okay, so I can choose the different details, and just by clicking on the options to include them, they'll be included in my drawing set. Okay, if I've got underfloor heating, this is how my underfloor heating would work. Okay, so I can choose all of those, and these drawings change based on the type and the complexity of the foundation system. For instance, when you're using a TC2 foundation, you'll see the different fibre cement options or stirrup options in the foundations versus what you've requested. Okay, so that's how you choose your additional details. I'll jump back to the main project screen. Well, I hope you found that a useful introduction to Specifi, as that's a pretty good place for me to end the webinar. If you haven't yet had a chance, please go to Specifi, register and create yourself a test project. I'll stay online for the next few minutes after we finish this recording to answer any questions you have. Remember, if you have any questions, comments or suggestions, we'd love to hear from you. Either call us on 0800 Specifi or email us on support@specifi.co.nz. Finally, I'd like to thank everybody for your time today, so thanks and goodbye. Cheers.